Standing by. Okay, welcome everybody. Let's see, hold on a second while I kill the sound so I don't get, so I don't hear a delayed version of everything that's going on. So welcome everybody. We're actually live, and welcome to the February meeting of the Grand Strand Astronomers. So we are the Myrtle Beach area astronomy club. This is our regular February indoor meeting. We do have a regular meeting every month, and we usually cover an astronomical related topic. So we also try to do an observing session every month. Of course, right now, because of the current health situation, we are not meeting in person. We were planning to try a virtual observing in February, but of course, anybody from this area knows what the weather's been like the last couple of weeks. And if we brought the telescopes out, it would really put the term bucket in light bucket. Unfortunately, that was not something that worked out. We are going to try that again in March. So we're going to try to do a virtual observing. So anybody that wants to try to stream, it'd be great if we can get a couple people that want to try to hook a camera to their telescope and try to observe something. If we get a couple of people, we can kind of switch back and forth, and we'll give it a try. That's going to be Friday, March 12th. So if you're interested in participating, you can, or have any questions, you can email me, and I'll talk about the email addresses in a second. So that's Friday, March 12th. That would ordinarily be our regular observing session, but again, we aren't really meeting in person. So the March meeting, the next meeting will be on the 25th, Thursday, the 25th of March. And the speaker is Denise. If you could just say briefly who the speaker is.
His name is Herb Baker. He's retired from NASA Houston, has a lot of space history, was really in with the Apollo astronauts, and his mom actually sewed the parachute on Skylab. So sort of some interesting stories. A lot of NASA history. Thanks.
Okay, so we look forward to that. The other thing is, speaking of email addresses, the club infrastructure is coming up. As you know, we were made a 501c3 organization as of the end of last year. We want to thank DreamHost for providing us hosting for email and website. They're providing that free because we are a nonprofit organization. So we certainly want to thank DreamHost for their support. And accordingly, we've set up some email addresses. I'll put them out on the listserv or the email list, but basically you can always contact the officers and and Denise, who's like our PR person, by emailing to info@gsastro.org. And then if you want to contact various officers or email various officers, you can do like secretary@gsastro.org or treasurer at gsastro.org. So we do have those up and running. So those are the ones we should use from now on. So if anybody wants to contact or ask questions at the club or reach any of us, you can do that, and someone will certainly get back to you. Speaking of that, we do have the email group. So anybody that's a member and you're not a member of the email group and not getting the emails, we host on Groups.io. Let me know, or you send something to info@, gsastro.org, and we'll get you on the group right away. Also, we do have a prototype, an early website up. So the website is definitely a placeholder. If you go there, prepare to be a little underwhelmed right now. It just basically says that we're under construction. But we do have the infrastructure up, and the website is actually, the infrastructure is actually working. We're working on the website design here over the next month or two. We do have someone engaged to do that. It's not going to be anything too fancy, but it will provide a good portal and a good jumping off place for information. If there's anything in particular you'd like to see at the website, would really appreciate you letting us know. Again, just drop an email to info@gsastro.org. So certainly, if you're interested in joining, you can either drop an email to info@gsastro.org or treasurer@gsastro.org, and John will take care of you right away. I think Denise put some information in the chat on that, which is awesome. Um, so if on related note, on for upcoming meetings, we're working on scheduling out the year. If anybody has any topics that they'd like to hear about, please let us know. Send me an email and we'll try to find somebody to talk about it. Or if you know somebody, doesn't matter where they are since we're doing virtual meetings, that might be a good person that might be interested in speaking, please let us know. And basically we'll reach out to that person to see if they're willing to talk. I find a lot of people are willing to talk. So really anything you want to hear about or learn about or a topic you want to learn about, um, you can go ahead and you just email us and let us know. In terms of events, well, right now, currently the situation doesn't really allow for in-person events. We're going to keep an eye on that. One thing about the current situation is, of course, in what I call COVID time, a couple of months seems to be a long time and things can change a lot. So we're going to constantly reevaluate that. And at such a time when it makes sense, or we can maybe have some events safely, we will start having some member events. Probably do member events before we do any public events. But eventually we want to get back to both when conditions permit, right? So before we get on to our speaker, is there anybody, and does anybody have any questions, comments, concerns? All right, so I guess not. So without further ado, we'll move on to our speaker. Our speaker tonight is Louis Kaysen. He's with the Low Country Stargazers, our sister club down in Charleston, South Carolina. So not too far away. The that club has helped us in our when we were first getting started, and of course has been working on some of the observing sites like Hampton Plantation that we intend to use. So we are indebted to their help and their support. They've always been very good for us. Lewis, he's been an astronomer for quite a while, an amateur astronomer, and one of his things is the moon. And so I wanted to get him to talk a little bit about the moon because it's something that people look at when they first get started in astronomy, and then they sort of stop, which is a bit of a shame because many nights like tonight, it's one of the few things you can look at, and you can always look at it no matter how light polluted your skies are. And so it's a shame that some people stop looking at the moon. So I'm sure Lewis will talk about that. But enough of listening to me talk. I'm sure you're ready to move on to somebody else. So I will throw it over to Lewis to start his presentation.
Great. Thank you, Ian, and thank you, everyone, for having me here. I'm hoping, Ian, they're seeing my slide up on the screen.
Yes, sir, you are.
Lone observing. Okay. What with this? And Ian, you just really made the whole point of my little talk here. Thank you. And a little more of my background. I'm going to talk about how I observe the moon and why I observe the moon. And my background is that this is a hobby of mine. I have no formal training or any professional background in any area of astronomy. I'm a rank amateur. And when I started observing back in my teens, which is back in the 60s, I did what everybody did. The moon was one of the first objects. And like so many of us, as time went on, we felt like we progressed. We got away from the moon. And then we just curse it because it's bright and interferes with us finding deep sky objects. If you're an imager, I'm a visual observer, it interferes with that. And I have found myself in the past 15 years or so going back to observing the moon and really enjoying it. And I hope my comments will inspire you at least to go out and take a look at it. And there's some great reasons to observe the moon. One of them is that it's easy to find. You walk out, you can see it. You don't need GoTo. You do not need a dark site. In fact, dark adaptation can work against you. If you've ever had the experience of looking your telescope and almost being blinded because the moon is so bright, part of the problem there is that you probably have gotten your eyes a bit dark adapted. And what you need is some ambient light. to help you with that. This is why it's so nice. You can just go outside and you don't even have to get mad at your neighbor because they have their floodlights on, because this ambient light helps. Your eyes don't get so dark adapted, so you don't get so blinded when you look. If you're looking at a lunar chart, try using a white flashlight to do it, to keep your eyes to not let your eyes get dark adapted. It's great because a small telescope, binoculars, very modest equipment can show you so much. Because it's easy to find, it's a good practice target when you start learning to use a telescope, because you can learn a lot to line up your eye with the eyepiece. You can learn pointing the scope. And those reasons also make it a great time, I think, for outreach. First quarter moon, which is when the moon's at its half phase, is a great time, I think, for outreach, because people can at least see it in the eyepiece. And especially if you with school children, and they're usually almost always amazed by it, but it's easy enough for people to line up their eye with the eyepiece. And, you take a look. I will point out as we go along, I am not an imager, but I have been taking some images of the moon with a cell phone in front of the eyepiece. Most of the images I'm going to show you are from just put the cell phone in front of the eyepiece, and I'll point out when it's not my image or point out when it is. Here's this next image. When the moon, you look at the moon, it's really pretty and everything, but it's all kind of chaotic. Does my white pointer appear on the screen, Ian? You said, okay, you've
Yes,
got
it
all
does.
these craters and it looks like chaos, and you got these dark spots and all that stuff. And it's very pretty to look at. And I have found that in learning a little bit about the science, which I'll get to in a second, has really helped my appreciation. But part of my point is, you don't have to care about any of that. It's so enjoyable to look at. You can go just look at it. I've learned a little bit about the science as an amateur. So when I talk about these things, it's what my understanding of what I've read. And my understanding is the Apollo program was really a watershed event for lunar and planetary science. And what came out of that, some things about the moon that came out of the sample, the study of the moon rocks brought back, is the moon was much older than people thought at the time. We're now looking at something that's maybe goes back 4.5 billion years. There's a good chance that may have been formed when a Mars or similar sized planet hit the Earth in a tangent blow and spewed stuff off, and it was formed. And one of the really things, the interesting thing was that when we examined the moon rocks, turns out all these massive craters and dark spots are probably the results of meteor impact. I remember the 60s, the majority thinking was these craters and the dark areas we call the mare, the seas, were probably of volcanic origin, and it was a minority view that this was related to impacts. My understanding is now that it's considered all these things are formed by impacts, the big craters, little craters, and even the dark spots. A little slide next showing the time scale here. I think basically what happened about 4.5 billion years ago, you had a succession of meteor impacts that hit the moon. And somewhere, basically, you had big holes in the moon, little holes in the moon. And after a lot of them were formed slowly over a period of time. Again, you're in this maybe 3 billion, 2.5 billion years. A lot of the big holes started filling up with lava. It didn't do it all at once, didn't happen real fast, did it in successions. And you kept having meteor impacts up to this late phase, up to what is felt to be the last real big meteor that appeared on the moon is the crater Tycho. And we'll see more of Tycho in a bit. It just puts you on a land scale of things here. You can even speculate that the meteor impact that created the crater Tycho was visible to the dinosaurs. And since then, the surface of the moon really hasn't changed. Probably small little things, there's debates on that. But as far as what we see in our small scopes, it hasn't changed. So it's interesting to me, these craters, they all look different, but it turns out there is a morphology to them. there is a shape. They do take a certain form depending on how big the rock was that hit it, how fast it's coming in, and the geology of the surface it hits. And basically, as a relatively little rock comes in, you've got a sort of little hole here, and you have some ejecta. Here's impact, and this floor gets fractured and forms back again. When a bigger rock comes in and hits, it's going to form something that's bigger hole, and it's going to take on a different form. You will now have a central uplift. There's a peak in the center that's formed. These walls will actually have what's called, they're sort of terraced. You'll have different layers. You'll have a crater rim. You'll have injecta out here. And a point we'll come back to in a little bit, this central peak is lower than the rim that you see here. This next slide is going to indicate two different morphologies. Now, this one on the left is a simple crater. It's enlarged. It is not as big as the crater on the right. It's smaller. And you see it's just like a hole there in a rim. But if a bigger impact will start producing something that looks like that has the central peak, these walls that are kind of layered or terraced and ejecta around, okay? So basically, you get a little rock, it does that. If you get a big rock, it's going to make a hole that looks like that. If you get an even bigger rock, it's going to make a hole that looks like this. Now, this is much bigger than the other crater we saw. This is called a ring basin, an impact. This is from the far side of the moon because we don't see this on the near side. Actually, what we see are remnants of it. But this is a huge hole, and you have these rings, circular rings. I'm sorry, I keep hitting the slide thing of mountain formations. Now, if you start looking through your telescope, you don't see all the craters looking simply like this. They do change over time. And, the question is, well, why do they change? There's no atmosphere on the moon. There is no weather on the moon. So like on the Earth, you have weather that changes things. That doesn't happen on the moon. My understanding is that there are no plate tectonics on the moon. Nothing, you don't have large plates of surface that are shifting around, bumping into each other like you do on the Earth. So that doesn't change the crater. And basically what's changed the appearance of the craters is that, other craters hit them and change their shape because they get impacted by other craters. And as I mentioned early, for many of them, lava has come in and formed and made a relatively smooth floor. And again, that happened in a particular period of time. I'm thinking probably 3.5 to 2.5 million years ago. And then you had, more impacts on that. So when we come to look at the moon again, it does start to take on, you get a little more understanding here that all of these craters, from the big to the little to these dark maria, are all impacts. Now, these dark maria would have looked like that multi-ring basin I showed you that's on the other side of the moon. It's just that over a period of time, they filled in, the floors have filled in with lava and then solidified. Here's an example of 3 craters together. It happens to be the crater Theophilus, the top one there, because that's what it says on the slide. And if you look at that up there, this is a moderate-sized crater. It's got that central peak. It's got terraced walls, and it's got an ejecta there. There's a crater next to it. Basically, you're wondering about an age of a crater. I think the more beaten up it looks, the older it is. You can see on this crater here, you can still see some of the central peaks there, but it's kind of filled in with lava. You've had a meteor impacted here, but even this meteor has probably impacted it and encroached upon the wall here. So this one, the Theophilus, is older than this one. Sorry. Now you've got another crater down here. It looks even more beaten up. There is no central peak. It's probably been covered with lava. You've had another crater impacted. This is probably of the 3, the oldest of the 3. But I think a point to understand is that all these 2 older craters, at one time, they looked like Theophilus there. and they had the central peak and that sort of thing. You notice you got a couple of other craters in here. Here's one that's almost completely buried from lava. So you start appreciating relative ages of craters, and you start to say, okay, even this one doesn't look like it's got a central peak. There was a day back when that it did, and it's changed from lava fills and other impacts. I talked about these Maria, big, broad, dark areas are probably multi-ring basins that eventually filled in with lava and solidified. These mountain ranges, my arrows pointing to this mountain range, this is probably the remnants of the rings that go around the impact basin that make it look like a target. Up here, they've kind of been obliterated, but this mountain range is left over. It used to be part of a huge ring that went all around this area. And it's interesting too to think that, if I'm understanding it correctly, you think of these big mountain ranges on Earth, I don't know, taking millions of years to form. Those mountain ranges form probably in a matter of minutes. Meanwhile, over time, you've had craters impact here. Here's two big craters. And I think you have to think that, like this crater here, there was a day it had a central peak, but not anymore. Lava flows filled in and covered it and such. Here's another area. This is a mare called Mare Nectaris, and it has always been an interesting, my little purple arrow points to a kind of a bright line, and that's called the Altai Scarp. And that is kind of a scarp or a mountain range. It's very pretty. It's great to see. It's easy to see in small scopes. But it probably, why is it there? How did it form? Well, I drew in up here it is probably one of the what's left of one of the rings from this basin here in the center. And I drew some little lines that would kind of imagine where the rest of that would go. So that is evidence of a multi-ring basin formed by an impact. And that Altai Scarp there is the remnant of that one of the concentric rings for that basin. Here's another set. I was able to take this. This is a cell phone in front of a 76 millimeter refractor. And part of what this tells us, this is the terminator where light meets the dark. And if you want to look at craters and mountains, this is the place to look. Because of the low lighting shadows, you can see the craters very well. You can see mountains. But part of my talk, I'll get to in a minute, it's not just the terminator where you want to look for stuff, because there's other stuff too. My arrow has pointed to a crater there that you can see the sun is rising from the opposite direction of that arrow. The sun's rising from this direction, lighting up what we would call the western rim. And there in the center is a tiny little crater peak, just catching the sunlight. And if we were observing this in another hour, that shadow probably will move and you'll see the entire central peak. It's very pretty when you see that. And I caught that, that's the crater Tycho. I would like to make a little bit, we talked about central peaks, and that the central peak is lower than the rim when these craters usually form. So we have to imagine, if we go back an hour or so where the sunlight's hitting this rim, there was a time where that whole center of the crater was dark, and the sunlight started to illuminate this western limb before it hit that crater peak, because the crater peak's lower than the rim, and then we happen to come in a little bit later, whereas the peak is just starting to catch the sunlight. Well, I enjoy catching things that make me understand what's going on a little better. Another image I took, this is the crater Copernicus. Take my word for it, there's a central peak in that crater, but I was able to catch it. So the sunlight, which is coming from this direction, is lighting the rim. It has not hit the central peak yet. So to my mind, that is visual evidence that the central peak is lower than the level of the rims. If it were sitting up above the rims, it should already be catching the sun. So I was happy to catch that. It helps me understand the shape of the craters. And, it's one thing to see in a diagram, but I like when I can see things for myself. And you look around too, there's some other stuff here. There's another crater with a central peak, but right in here, just as the outline, there's probably a crater submerged right in here You can just see the outlines under lava. In fact, there's a term for that. It's called a ghost crater. And you can just see it when the lighting's just right. But underneath that is a crater that used to have a rim and a central peak and such. So this crater is younger than that crater. I hope I can make this clear here. I like finding things that illustrate certain points that I've read. This is not my image on the right. This is the crater Clavius. Got it off the internet. It's one of the biggest craters on the moon. And one of the things I read, this is an old crater. It's been impacted by a bunch of different craters. I doubt there's really a central peak there, but what's more interesting, an interesting point about Clavius, it's so large that by our understanding of crater formation, it really shouldn't be a crater. It should be a multi-ring basin. And it may be all these craters that surround it have hidden the basin, but it looks like a crater and it really should be a multi-ring basin. And one of the interesting things is in this crater, the crater is so big that the curvature of the moon makes the center about as high as the rims, okay? This picture on the left I took, and it's kind of fuzzy because I took it in daylight, but the shadow pattern was showing me something I tried to capture. My arrow is pointing to this crater Clavius, and the sun is coming from here, and both this side is in shadow and this side is in shadow, where my little arrow is still in shadow. If you are standing in shadow right here, your horizon will be this central part of the crater. You would not see this rim. In this central part of the crater, you can see it is catching the sun. All right. If you go to this crater here, if you can see my cursor where the sun's rising, if you were right there at sunrise on the rim and looking towards the sun this way, the rim's going to define your horizon. But here, if you're standing in Clavius, this central part, because of the curvature of the moon, the crater's so big, that's your horizon here, not the crater rim. And I'm not sure if I'm explaining it well, but I think the shadow pattern shows that, and I was happy to capture that with my little 3-inch refractor and a cell phone. Back to lighting. Lighting, the same object of the moon looks different under different lighting conditions. If you see a crater in the first half of the lunation, 2 weeks later on the setting sun, it's going to look different. Here is the crater Tycho at sunrise, where my red arrow is. We saw it a moment ago. That's what it looks like. At full moon, this is what the crater Tycho looks like. And it's one of the predominant features of the full moon. It has a ray system from impacts coming here and here and here. There's actually a dark area, which I don't know why, around the moon. You don't see that until the sky gets high. This crater was probably impacted from a very tangential hit coming from this direction, because you see the rays flaring out, but there are no rays here. And this was the one, this is probably the youngest big feature on the moon. They're calling it about 109 million years. And this is the crater that you can think that the dinosaurs could have witnessed the impact. In fact, there have been meteorites found on Earth that are linked to the Tycho impact. Full moon is a great time to look at rays. You don't see rays at the terminator. So as I said earlier, terminator is where a lot of the action is, but there's more action elsewhere too. You see ray systems at full moons. Here is two other, this crater and this one, they have a big system of rays formed by impact, okay? Very different looking from the Tycho, and as my understanding is it was probably impacted by a meteor coming at a much steeper angle than the tangential angle that hit Tycho, and therefore produced a pattern. Okay, a little thing about relative ages of craters. When you're looking at a crater and you can see a ray system, it is a relatively young crater. Okay, because the ray systems eventually disappear. My understanding is probably kind of scoured away by micrometeorite impacts over time. So craters with rays equal young craters. And you can see the ray system very nicely at full moon. Go out tonight, tomorrow night, and Saturday. Take a peek at the full moon. It's gorgeous. A little more about ray systems. This doesn't show the ray system real well, but it showed 2 points I wanted to make. A point I wanted to make about rays. Again, this is Copernicus, and you get the hint of all this rays around Copernicus. Well, here's another crater, Eratosthenes, it happens to be. It looks pretty young too. It's got a central peak. It's got terraced walls. It's got ejecta, but you would tell for surely we get full moon. There's no ray system around this one. So both of these are relatively young craters, but Tycho here must definitely be the younger crater of the two because it has a ray system, and that crater, Eratosthenes, does not. It's gotten popular in recent years. There are lighting effects that appear at the terminator, and they're reproducible each month. And these aren't formations. It's just the way for an hour or two, the rising sun will illuminate objects on the moon. And the popular one is the red arrow here called Lunar X. And it looks like a little X, and you'll see it for a couple of hours there. It happens every month. The thing is, when it happens, may not be 9 o'clock at night. It might be 2 in the morning. It might be 12 o'clock in the afternoon. So by the time you get around at a nice observing time to see another one, it'll probably be raining. So you keep looking for it. After a while, you will see it. You look up Lunar X, and you can find times for it, but it's really pretty to see. But there's more letters on the moon because while X is forming, so is lunar Q right here. Looks like a letter Q. Looks more like the letter Q about 30 or 40 minutes before X forms. And while that's forming up there is a little lunar V by the green arrow. So that's our lunar alphabet. You have X, Q, and V all formed there. And this is probably a day before quarter moon, a day before the moon's really half. Other lighting effects are fun to see. This is not my image. I took this off of the internet, but it illustrates what's called a sunrise ray in a crater, forming a pattern of light. This is the crater Maginus. I walked out, I was surprised by a clear sky Monday night, took my little refractor out, and the most noticeable thing on the moon was what I saw here. It was actually, when I saw this, it was actually more narrow and really looked more like an arrow. Someone in the internet has proclaimed this little sunrise ray that you see from time to time in the crater Maginus as the arrowhead. And when I saw it, it really looked like a thinner arrow. After watching it an hour or two, it was more like this. But I found a picture of it on the internet. That's just another example of fun things you see on the moon. Another very fun feature, beautiful feature to see on the moon is called Rupus Recta, the straight wall. This is an image I took through a 76 millimeter refractor, again, cell-phone in front of the eyepiece. And it's that little straight line there. And what this is a fault line. And this area here, this is the sun rising this way. So this is east and this is west. And the western portion has dropped or fallen here. Producing this line is probably, that line is probably about 65, 70 miles long. This is not truly a wall, but it has a slope of, I think, 20, 25 degrees and probably rises anywhere from 8 to 1,200 feet above the western floor. We can tell that the east side is higher than the west side, or the west side is lower because it's casting a shadow with the sun coming this way. So this side is lower than that side. And just to confirm that to yourself, come back 2 weeks later, watch the setting sun coming this way, and what you will see is not a dark line shadow, but a bright white line as the sun is illuminating the face of the slope there. Over here, talk about fault lines. This is something, I've circled it, this section of mountains, which we saw earlier, which is probably part left over of a concentric ring on this basin here of Imbrium. is called the Alpine Valley because they named these mountains the Alps. And it's really something called a graben, which I understand what you have are two fault lines and the ground drops between them. And what looks like a mountain valley is formed there. Again, you can see this in a small scope. This is not my image of it, but it's a popular object. And while we're here too, notice the different variations in the mare surface. It is not uniform. You see probably indicative of it forming over different times and different mineral deposits coming in. In fact, looking away from the moon, I did capture this picture, and the view I had through the eyepiece was much more dramatic, but you'll see some dark areas of the moon, of the Maria. Here, the green arrows in this little stretch here was very noticeable at the eyepiece, called dark Maria deposits. The Apollo 17 landing site was over in here, where I'm at, that area. It sampled some of this, and that dark area, you'll read about it being referred to as volcanic ash, but what it really, I think, were these fine little spherical black glass beads. Felt that at some point there had been a vent that released lava, shooting it into above the surface of the moon, which of course then immediately solidified and left these deposits here. So again, looking away from the Terminator, there's stuff to see. And if you look, this is Sea of Tranquility, the Sea of Serenity. And if you learn those, every time you look, if you look, you'll see this dark Maria here. This was a particular night that for some reason it really showed up well. I got it in my image, not nearly as good as it looked at the eye. And meanwhile, while this was happening, here's Lunar X that was forming. Lunar Q was over here, and Lunar V is right below this arrow right here. Other odd little formations. This is one you can see. My arrow is pointing to a bright spot there. And this is a swirl. Interesting object. It's called Reiner Gamma because it happens to be near this crater, which is Reiner. But my understanding is it's not associated with that crater. In fact, it's not associated with anything. And interestingly, when the Apollo astronauts orbited over this, they measured a very strong local magnetic field over this area. And there are a few other of these swirls that are located on the moon. This is an easy one to find when the lighting's right. It's interesting to see, but its surface, it doesn't go above the surface because it never casts a shadow, and it's not associated with a ray system. I've read some conjectures of what might be have caused these swirls, but I don't think anybody really knows. So it's a fun little mystery spot to look at on the moon. One other little great lunar phenomenon to look at are occultations, when the moon passes in front of a bright star. I go out Wednesday evening and there's a 3.5 magnitude star in Gemini and the moon's approaching it, and I hold the camera up, I get a picture, and I was very surprised. You can see the red arrow. I actually was able to capture the star, and that was within 5 minutes of the moon moving this way, occulting the star. And what you will see in a lunar occultation, when the moon covers this star up, the star goes out instantly. It's been described like someone turns off the light, and that's exactly it. And I think you can take that as visual evidence that the moon has no atmosphere, because if it had atmosphere, we would expect the star to fade and then disappear. But it's something dramatic to see. If you blink, you will literally miss it. And I was very happy to capture that image, but occultations are other things to look for and have fun to look for on the moon. So in summary, I really enjoy looking at the moon. I find it very enjoyable that all these dark areas and craters, this was a mystery solved for me as an amateur astronomer. Back in the 60s, debate on what this went on, what caused these things to happen. And to think now that all these dark spots, big craters, middle craters, little craters, are all an impact process that we understand that now. I find makes it more enjoyable for me. But you don't have to know that. Just go out and look at the moon. I like the Cole Porter lyrics. I want to ride to the west ridge where the west commences and gaze at the moon until I lose my senses. I can't look at hobbles and I can't stand fences. Don't fence me in. That might appeal to you. Go out, take a look at the moon. And Ian, if I can I'm going to get rid of sharing the slideshow and just have me on camera. I have a couple of resources I'll show you and I'll be finished. So can I hit stop share?
You can.
And people can see me. Okay. How do I observe the moon? Right now, I have a TeleVue 76 refractor. I've had that about 1.5 years. Most of my observing the moon through my amateur astronomy has been with an 80 millimeter achromat. You do not need sophisticated equipment. Everything I've shown, all these things are visible in small telescopes, and they're visible at less than 100 power. I have an 8-inch Dob too, and that's fun. How do I take the images? Because I had a couple of TeleVue eyepieces, I bought a TeleVue phone-made holder. So the cell phone goes into this thing here, and you center the cell phone camera over this little hole, and this little hole will screw into a TeleVue Ethos eyepiece, and that's how you hold it. There are other holders you can get out there if you don't happen to have expensive TeleVue eyepieces. I have had some luck at just holding the camera, but having something to steady the camera has really helped me a lot. But I have to say, this image right behind me now, last night, I had a 25 millimeter Plossl and my 8-inch Dob. I held the camera up to the eyepiece, took some images. They were all terrible, except this was really nice. Okay. Books, moons, charts. On my iPad, I have something called Moon Globe HD, free download, works well. Sky and Telescope has moon charts that I work with. They're laminated. They look like this. Then they unfold, and you've got big charts of the moon. And they have one that's upright, which you can use for binoculars or Newtonian, flip it over. Or you can get the mirror image one, so it's oriented for a refractor or catadioptric with a diagonal. Fun books. Charles Wood has a book called The Modern Moon, and this is where you get into the science of it. And you can get with a little Lunar 100. You can get this on the internet. There are 100 objects he picks out that point out things about the moon, certain points he's trying to make in his book. There are a ton of books on the internet, a lot of places to go to find resources these days. That's basically how I do it. I enjoy it a lot. And I guess I'd say to you, if you aren't going out looking at the moon, you're wasting 2 weeks out of the month if it happens to be clear. So go out and take a look and decide for yourself if you want to keep doing it. But since it's really simple equipment, you don't have to set up much at all. Thank you, Ian, and thank you, everybody, for having me.
Well, thanks, Lewis, for a great presentation. Does anybody have any questions?
I see there may have been some. Okay, I'm just learning how to use this stuff here. And okay, there's just some chat stuff, but I don't see anything directed at me. Okay. Good. But if you want to direct something to me, that's fine. I'm happy to try to answer.
Any questions? I also want to put a plug in for that book, The Modern Moon. That's actually an excellent book if you want to learn about the moon. That's it's very detailed, but it's still written in a pretty accessible way. So,
what's the name of that book again?
The Modern Moon: A Personal View by Charles A. Wood.
Okay.
And I highly recommend to go ahead and order his Lunar 100 also. Oh, the Astronomical League has, I think, a lunar observing badge you can do. And you go there, you download the list of objects. you don't have to report it in if you don't want, but there's a great list of objects to guide you to look for stuff. I think they actually have two now. They have a lunar
Yeah, they have a
observatory.
lunar too as
Yeah,
well.
but the
Um,
Astronomical League has great stuff. So I recommend going to that, using that as a guide to find objects. And if you want to go and, do the busy work of filling out, sending it in, getting your badge, that's fun too, but you don't have to do that.
Yeah, so the Lunar Club is actually a really good club for the
Yeah.
Astronomical League, because it starts out with a bunch of naked eye observations,
Mhm.
and then it goes to binocular observations and then telescope observations. But the telescopes are all very modest, so even if you don't have much equipment, you can actually do quite a bit of the lunar observing program. So I definitely
Yeah.
recommend that. You have any other questions?
So you said that the Apollo sampled an area that it looked like beads. What was that area again?
Okay, yeah. I was pointing out some dark Maria deposits, and
Okay.
the Apollo 17 landed in an area that was accessible to that. And these were all tiny little, what appeared to be tiny little glass beads, but were actually probably the result of a volcanic vent. If I don't know anything about astronomy, I really don't know anything about geology, but I get the idea that a volcanic vent millions of years ago involved under pressure shooting lava, molten lava not into the air because there's no air on the moon, but off the surface. It immediately froze and formed, instead of ash. They sometimes call that volcanic ash on the moon. You kind of think of it that way, but it's not really what we think of as ash. But that's what those dark Murray deposits are from. And pay attention to it. You look around, you'll start seeing dark spots. But that long little strip is kind of a fun one to look for.
Are you excited for Artemis?
Yeah, yeah. I try to get excited about everything, but yeah. I think the fun part was back that Rainer Gamma, that swirl they don't know anything about. I don't know if you're a certain age, I think you automatically get an image from the movie 2001 when you read about that. But I saw that object last night on the moon, Rainer Gamma.
Do you recommend a moon filter when you're looking at the moon?
I have not. I have them, and I ended up not using some so much, but they're cheap and they might work for you. It's worth a try. It's whatever works for you. Again, I've paid more attention to not letting my eyes get dark adapted. But you're out looking at a bunch of things. You're at a dark site. Maybe it's not a real, maybe it's not a full half moon. So you can still see deep sky objects. And you can go ahead and put that filter on so you don't get blinded too much by the moon. Because then after look at the moon a little bit, you want to go look at some deep sky objects. And I think it has a place there. It works there. I know there's some people who use it routinely.
Yeah, a lot of it probably depends on the size of your telescope too. If you're using
Yeah.
a smaller one,
Yeah.
you might be able to get away with it. I know, like if I'm using my 8 or my 11, I have to have a moon filter because it picks up so much light.
Yeah.
I mean, you can almost pick up a moon burn off that stuff, you know?
Yeah. But again, try looking at a flashlight before you look in the eyepiece next time. But you're right; it's probably easier. You get a big daub, and it'd be easier just to put a filter on just to help you out.
Of course, if you're doing photography, you don't want to use the filter, but
Well, that's another thing I say about photography. The moon is so easy. I'm not an imager. It's not going to happen. And every time I try to take a cell phone picture of the moon, I remind myself I'm not going to be an imager because I lose patience just doing that. Because you're going to do some fiddling. It's even with an attachment, you have problems getting the eyepiece and the camera thing lined up. And so if you think you might like imaging, the moon's a good place to start because, you don't put out a lot of equipment. And if you find yourself cussing and throwing the phone down on the ground, you think, well, maybe imaging's not for you, and you save yourself a lot of money.
Yeah,
Yeah, I've-
there's several attachments for cell phones that you can attach to any eyepiece that let you kind of adjust it in 3 dimensions.
Yeah.
So
It'll still take some, yeah, it'll still take some fiddling.
so that's a good way to get started with imaging if people want, you know, and don't want to invest in any equipment. So
Back to equipment, that I will say, you know, I do have, if you want to spend some money, I have a pair of bino viewers, and those are really nice. But the older I get, the lazier I get, and a couple of eyepieces just in my pocket, you know, especially if I'm using a small refractor so it doesn't weigh a whole lot. I use solo eyepieces too. So my best views are in the bino viewer, but you know, I get really good views with a single eyepiece. Let's not make this complicated, especially if you just want to try it. Don't go out and buy a bino viewer just to look at the moon.
I'd recommend people try to look through a bino viewer if you can before you
Yeah.
buy it, because not everybody can merge images.
That's true
I know
too.
I cannot merge images even in a perfectly collimated bino viewer.
No.
And
I do fine. And those are my best views, but you get such a good view just plopping a little eyepiece in there. If you don't want to fool with stuff, out you go. You know, what works for me is just having easy, quick equipment to set up. That's where I am at this point.
any other questions? Or questions on anything, not just moon related, anything club related? Upcoming events, anybody wants to talk about? Any kind of astronomical events? Yeah, I know, unfortunately, we don't have a lot of planets up right now or anything, so I think we're in a little bit of a dearth of interesting events. We had a whole bunch last year, so.
Mark, are you getting warmer where you're at least? Because I know you're out there all the time doing viewing and pictures all the time. Any
I
warmer?
haven't had to scope out for quite some time. So we just barely got above 30 the other day. So we were in 40s just for one day a couple days ago. The snow's starting to melt. I was going to try to get the scope out tonight, but they're calling for fog and low clouds moving in front of and in advance of a front. But haven't had the scope out for several months, so I'm ready to go.
Yeah, I feel the same way. We've had tons of rain. We haven't had snow, but we've had lots of moisture in terms of rain and clouds, and it's just been just night after night of just terrible weather. Where usually the winter is pretty reliable for us, but
Well, your snow perseverance rover that made all the weather channels and everything, right? All the news networks.
yes, I don't know if everybody's aware of that. If you saw that the person that sculpted a Perseverance rover out of snow,
that was
made
Mark.
all the national news, that's actually Mark that actually did that.
I didn't know that.
Yeah. So he was the one that actually did that. So it was pretty cool that it got pushed out everywhere. So
Yeah, it's suffering pretty good right now. So it's starting to melt, and a couple days after I made it, we had some warm temperatures, and then it melted, and then we got all this snow, so it was completely covered. I will note that we do have most of you probably know, we do have well, it's actually a total lunar eclipse coming up on May 26th, but for most of you guys on the East Coast and here in the central US, we will only get the partial view because it will be setting as it goes into totality. So people on the West Coast and Hawaii will see that total lunar eclipse in May.
Ian,
Yeah,
I just did a quick search, and it's possible that March's lunar X is going to be in a good time slot. It's Sunday, March 20th, 0200 Universal Time. If we're on savings time, to me, would be Saturday, March 19th at 2200 for us, 10 o'clock at night. Lunar X. And when you're there, look for Lunar Q and Lunar V while you're at it.
Oh, that's pretty cool.
And I just did a quick search, and so you don't have to remember this. Just go search and look again. But But March might be a good one, especially if I just recited the times wrong. You'd want to go check that again.
So hopefully we'll get some good observing weather in March, and people can get out with their telescopes and get a little bit of viewing going on. So sorry, I was thrown off. I've got the time delayed version on my screen as well, and I saw Lewis start talking on the time delayed version, and I thought he was speaking. So it's the thing about running these Zooms. It's a little hard to keep track of all the different things at different times, So my brain's not that big. So all right. So any other questions on anything astronomy related or things like that? There's been various virtual observing sessions that you can participate with all over the country, like Lowell Observatory has been doing some. So if you just want to actually see some, I know McDonald's Observatory in Texas has also been doing some live star parties. So there are some observing opportunities if you just want to get a chance to see some things.
Yeah, and I shared some in the chat. There's some other opportunities for astronomy education stuff, like astrophotography is one, and there is a course, I took it last year, called Girls on the Telescope from the Astronomical Society of the Pacific, really trying to encourage girls in astronomy. And they do like a month-long class. And it was really nice last year. I got a certificate and a year's membership to the Astronomical Society of Pacific. Now, I don't know if they're offering that again this year, but it was, really nice workshop that they offer. So just want to share that. It's on our Facebook page. So if you're interested, or, you want to find out more, you're interested in doing public outreach when this goes away, it's a great class to sign up for. So, and I think they do programs too with the Girl Scouts and that kind of stuff. So to help with the Girl Scouts pre-COVID to get their badges and stuff like that.
Ian, on your website that you guys are building, are you planning on having a section for your members there to post or to submit images for the gallery or whatever?
Yeah, that's a great question, Mark, and it's something we've actually been talking about. I do want to have something like that, although we were what we're still discussing is whether that's going to be something that actually stores them locally on our server or just points to other services, because so many people use things like Astrobin. That I think what we're going to have is something that acts sort of as a portal or an aggregator that says, oh yeah, look, here's Mark Brown's images, and links to wherever you would store them, right? So I'd be interested if you had any thoughts on that. But that's kind of the way we're going to go. But yes, we do want to be able to showcase member images, and but at the same time we realize people are posting to other services, right?
Right. I know it's time consuming to keep up the website to do that too.
Yeah, I think we'll be okay on that. I just rather than store them locally, that's so many people do use the various services out there. I assume you use a service, or do you actually like one of the Astrobins, or some
No, I
people
don't.
use Flickr or SmugMug or
No, I don't right now.
Coffee Cup? Okay, so you would actually say it'd be good to have some local storage as well. So maybe we need to do both.
That's up to you. I mean, I'm trying to get my own website back up. It's just, I got to find the time to do it. And I used to have my own website where I sold my images. So I want to get that back up and running.
See, that's another thing. If you have something like that, then we could link to that in terms of, saying, okay, well, here's how you look at the, people's images, right? And so, but we are looking at doing that. I would love to hear anything like that. Any comments on what you'd like to see in the website? Just in English. You don't have to, not asking you to design any parts of the website, just in English. And so a person that's going to be working on the website for us can try to implement the various things. So, the various features we want. I'd like to, have it be some pretty good information for astronomy in the area. You have some upcoming events, some weather information about, predicting the weather. You know, there's some pretty good, there's a couple really good sites you can use and a couple good, really good models you can use. And, but it is a little tricky sometimes to read them. So I thought I'd put some information on there for that. So, I know there's an astronomer somewhere out in the Midwest who does a lot of presentations on using those models for astronomy. I don't know, Mark, if you know his name. He's somewhere fairly close to where you are, I think. But I can't remember his name off the top of my head. But beyond that, if nobody has any other questions or anything they'd like to discuss or ask about, I want to thank everybody for attending, and for all those people that are watching live. I'm going to go ahead and turn off the live right now.
Thank you, Lewis. It was a good talk. We appreciate it.
Yes, of
Thanks,
course. Thank
everybody.
you